Welcome back to another video from Newton Mutant channel. Today I have something special, something probably you've never heard of before. Let's straight get into business then. I'm pretty sure you've come across problems asking you to determine the next number in a sequence, right? From school exams to interview questions, those problems are everywhere. What you see right on this screen is a similar, yet a very easy sequence that you've seen. Anyone would rightly point out that it's the sequence of square numbers, so the next term in the sequence would be 25, right? That's the obvious guess. What if I told you that it's logically possible that the next term of this sequence can be any number? Yes, my friends. Literally, it can be any number, and I'm going to prove to you why that is so. Stay with me for the next 3 minutes to know the reasoning for this. And a kind reminder to like this video and subscribe me as well. Alright, let's start with the basics. To find the next term of a sequence, what actually is the technique used? My friends, you know that already. We use the nth term or Tn for that. As long as the nth term satisfies the given terms of the sequence, we are good to use that to determine the next term. In that sense, the nth term of this sequence would be n squared, as all of you would agree, right? Let's quickly validate that. We plug in the values 1, 2, 3, and 4 for n, and we derive t1, t2, t3, and t4 as 1, 4, 9, and 16. So t5 would be 5 squared, which is 25, hence nth term being n squared makes sense. Okay, now comes the grand revelation. What if I can write another nth term that would still satisfy the first 4 terms? For example, have a look at this. This nth term also has the generic n squared part first, but after that I have included a product of 4 terms. Let's see if this holds true for the given terms of the sequence. First term, or t1, would be 1 squared plus 1 minus 1 times 1 minus 2 times 1 minus 3 times 1 minus 4. Note that the 1 minus 1 term equals 0, hence it would make the whole product 0, therefore t1 equals 1 squared, or 1. Similarly, if we plug in 2 to find t2, you will see that the 2 minus 2 term in the product would make it 0, hence t2 equals 2 squared, or 4. This result holds true for next 2 terms as well. t3 has a 3 minus 3 term, and so it equals to 9. t4 has a 4 minus 4 term, and so it equals to 16. Alright, I've shown that this new nth term is valid for the given 4 terms of the sequence. Simply, what I did was including a product that cancels off, in addition to the generic n squared. Now let's come to the question. What would be the next term of the sequence, or t5, if we use this nth term? Let me plug in n equals 5 here and see. This time the product won't equal to 0, and we get 25 plus 4 times 3 times 2 times 1. The product part equals 24, hence overall t5 equals 25 plus 24. That gives us the answer, that t5 equals 49, if we use this nth term instead of simply using n squared. My friends, I think you're fascinated with this result, but hold on. I promised you that the next term, or t5, can actually be any number, didn't I? Now let me show how to write the nth term so that you can have literally any number you want as the next term of this sequence. Let's say k is the number you want as the next term. K can be anything. 1500 or 20 million or negative 0.5 or literally any number. Now the question is, to get t5 equals to k, what should be the nth term? Look at this. It's a slight modification of the same nth term I used before by introducing an additional term to the product. Let's plug in n equals 5 here and see what would t5 be. The additional part has 24 in its denominator, and this nicely cancels off with the numeric product that also comes as 24. Then the 5 squared term also cancels off with the 5 squared coming from the additional term introduced, and my friends, we're left with t5 equals to k. Okay, I used this analogy with a basic sequence to show you how limitless your choices can be. Try this with any sequence. You can always write an nth term to result whatever the number you want. I think this video helped you to have a different perspective about number sequences and admire the beauty of it. Also remember, while this would be a fun thing to know, don't go and lose your marks in exams. It would be best to always use the standard generic nth term in such scenarios. Alright guys, I'm signing off then. Hope to see you soon with some cool math stuff. Goodbye.